The hazard analysis process is closely linked to the system safety process, and as such, we do not stop at just identifying hazards. The system safety process is what's called a closed-loop process. We'll take a closer look at a closed-loop process. First, we'll do so generically. We'll just look at a generic closed-loop process, what that means, and then we'll work through how a closed-loop process applies to system safety, and then finally, we'll look at the closed-loop process as it applies to our 10 hazard analysis steps. So let's work into the generic closed-loop process. The first part of that is to define the process and the problem. What is it that you're working with? Once that's done, one must ensure that measure anyway, the current performance. Get a baseline status. How well does the current system perform? Is it effective? Is it efficient? What improvements can be made in that area? We're looking at the baseline. What is the current performance? Measure that. Next, we analyze the system or the process for any problems. The problems of efficiency, effectiveness, safety, any problems and the root causes of those problems are analyzed here in step 3. This is actually supposed to be a number 4. This is step 4, improve. That is, figure out how to fix the problems and implement improvement actions. And then step 6, this is actually supposed to be step 6, control. Control is to maintain the improved process, and that leads back to step 1, where the process continues by defining and measuring the system or the process, including the improvement actions that were implemented in step 4. So it continues in a circle, continuously evaluating and continuously improving the system as it goes. That's a generic how a closed loop system or closed loop process works. So how does that apply to system safety? Here we go. To begin with, remember, step number 1, here we are defining and describing the system itself. Second, we identify hazards and consequences. We're measuring the current system performance. Next, perform a risk analysis. Analyze hazards and identify the risk levels. And then, step number 4, assess the risks. Once we know which hazards present the highest risks, we can generate a priority order to address and mitigate those risks, which leads us into developing an action plan to mitigate and implement those mitigation strategies to reduce the risk and enhance safety. And finally, we validate. Validate and monitor the results to ensure our mitigation strategies are working and that they did not introduce further hazards. So if the system was modified due to risk mitigation strategies, we must reevaluate the system for any newly introduced hazards. If no system processes were modified or no new processes were introduced, then we go back to the top to start the process all over again. That's continually monitoring the system for any changes in environmental hazards, for any new hazards, or evolution of hazards against the system. This helps us continually evaluate and, again, for continuous improvement of the system. So we talked about the closed-loop process generically, the closed-loop process as it relates to system safety, the system safety process, and that hazard analysis process is hand in hand with the system safety process. So now let's go to the 10 steps of the hazard analysis process that comes from our Erickson text. First, plan the hazard analysis. Haphazardly jumping into hazard analysis without planning, it can lead to confusion and overlap and gaps and mistakes. In the planning stage, we're supposed to define and document the parameters, select the hazard analysis technique that we're going to use, decide which risk criteria, that is the likelihood and the severity in the risk assessment matrix, definitions, the likelihood and severity definitions that we're going to use. All that happens in this plan the hazard analysis stage. Next, understand system design and boundaries. Remember from PowerPoint 2, we must define the boundaries of our analysis, very beginning of the course. Define the boundaries of our system so that the analysis, we know where it must stop. It doesn't get overly cumbersome. Next, get the tools needed for the analysis, the checklists, the diagrams, etc. Step number 4. This is one of the most difficult steps. You will continue to hear this throughout the class. One of the most difficult steps is actually identifying the hazards within the system. Root out and find the hazards. The rest of PowerPoint 5 after this section when you're in the actual PowerPoint presentation itself, is dedicated to different ways in which hazards can be recognized. The hazard analysis technique that was chosen at the beginning is actually applied here in step 4. Okay, so in step 5 now, we're going to validate the hazards. It is one thing to decipher hazards on paper, but a peer review of the hazards can validate the process and the results, for that matter. Someone or a group of people, subject matter experts who work with the system daily, should be drafted or inquired of to validate the hazards that are generated by the hazard analysis technique. Make sure that they make sense. Remember, common sense is not thrown out with this logical process here. Step 6, the next step, assessing the risk, is how we can identify the amount of danger a hazard brings. By comparing the likelihood and severity ratings, we determine the hazard's risk index. The Air Force System Safety Handbook gives us an example of the risk matrix and resulting hazard risk index. The index, the composite severity and likelihood, determines the level of hazard. So you have the severity categories and the likelihood categories. As you compare those, it gives you the hazard risk index. The hazard risk index then determines what level of risk you have, high, serious, medium, or lower. Determining the level of risk, we figure out how dangerous the hazard is, and then here in step 7, we can prioritize. We can use the hazard risk index to prioritize the mitigation strategies. Which hazards are most dangerous? Which ones do we address first? The ones easy to address, or do we address first the ones that are most dangerous? This step, number 7, helps us prioritize and then mitigate risk. And we can mitigate risk through things like fail-safe mechanisms, like a squat switch on an aircraft landing gear, and redundancy, like 2 separate power sources to power a safety-critical circuit. When considering risk mitigation strategies, remember to use the hazard reduction precedents that we discussed at length earlier in this course. So after we put all the controls in place to mitigate the hazard, we must then ensure the strategy was implemented as planned and is working as we thought, working effectively. We call this V&V, verify and validate. Finally, or not finally yet, but unless the hazard can be eliminated, residual risk will remain. A decision needs to be made as to whether to accept the residual risk or whether to not accept the residual risk. That decision must be made by the appropriate level of authority in the company. Determine that in advance during the step number 1, the hazard analysis plan. The higher the residual risk, the higher level of management that should be involved in the decision of whether or not to accept that risk. The Air Force System Safety Handbook gives an example. Finally, the hazards and mitigating strategies are tracked with the information that's then plugged back into the first step to redefine and reanalyze the system, providing for that closed loop process and continuous improvement of our system.